Hello everyone, hello dear partners, good morning from China. This is Rainer and Green, and today in this presentation, we will introduce our new release two payloads for error serving solution. One of them is Zenmuse P1, and the other is the LiDAR solution, Zenmuse L1. So it is actually important, and so I propose to wait for a few minutes because I see there are still many other partners entering in, and thank you for your patience. And later on, I will start this training and give more information to you. Okay, I see most of our registered participants already entered in this meeting room. And before starting, could you please tell me whether you can hear my voice clearly? And I will open a stream. And whether you can see the stream clearly with DJI P1 logo, efficiency through flexible full-frame photogrammetry. Wow, thank you guys. Thank you for your feedback. Thank you, thank you, thank you. So, okay, and I propose you during this presentation, you may have some questions because this is our new released payloads, and it is actually the first aerial servering and mapping solution compatible with Metro 300 RDK platform. So it will be very interesting, and so let's expect it. And I will just start this presentation. And we have some also official. We have some official introduction video included in this webinar, but one of them, actually the introduction video of L1, I suppose the rate of it is too high. So maybe there will be some problem when you enjoy the video. And so let's start. Hello everyone, welcome to today's webinar. And in this presentation, we will go to introduce our two new released payloads, Zenmuse P1 and Zenmuse L1. And Zenmuse P1, first we will introduce it. It is our new professional high performance, flexible for frame photogrammetry solution for error serving and mapping scenarios. And before the detailed introduction, I'd like to show our official introduction video. In this video, you will first collect a preliminary understanding of this product, and it is very interesting, so I hope you can enjoy it.
The world of work was once again revolutionized when DJI launched the new enterprise flagship platform, the Matrice 300 RTK. With the new Zenmuse P1, unlock more of its potential. The P1 integrates a full-frame camera with interchangeable fixed-focus lenses on a 3-axis stabilized gimbal. It is an efficient, accurate payload designed for photogrammetry. For the first time, DJI uses a full-frame sensor with more microns in each pixel to give you higher image quality. At 45 megapixels and with short shooting intervals, the camera can capture high-resolution images of large areas in short flights. In just 4 flights, 140 minutes. Collect data for 10 kilometers squared of 2D orthomosaics. What's more, the P1 syncs time across the camera, gimbal, flight controller, and RTK module to deliver centimeter-level accurate data. Its global mechanical shutter with a shutter speed of 1/2000th seconds prevents the jello effect, keeping images crisp even during high-speed flights while meeting accuracy requirements of 1:500 scale cadastral surveys. Thanks to the flexible 3-axis gimbal, Smart Oblique Capture simplifies oblique photography for you to quickly generate highly accurate 3D models. In areas with elevation changes, flight paths that follow the terrain let you fly safely while improving the accuracy of data outputs. Traditional geological surveys required teams to hang from dangerous slopes. Now, with the M300 RTK and P1, snap of the object photogrammetry missions are easier than ever. Vertical slopes and mountain ranges can be modeled with a millimeter-level resolution, so teams can investigate, measure, and evaluate these hazard sites. Use this combo for AEC and surveying applications to quickly acquire 2D and 3D data for all phases of the project lifecycle, including design, acceptance, inspection, and maintenance. In emergency response, immediate access to the latest intel is crucial. When used with DJI Terra, the solution enables real-time mapping, so teams can have eyes on a large area to quickly make informed decisions. The Zenmuse P1 and M300 RTK solution is unprecedentedly efficient, accurate, intelligent, and safe, setting a new benchmark as your new go-to tool for aerial survey.
Okay, I hope you can collect overview impression of P1 while this video. And as showed in this video, P1 is a high-performance, versatile surveying payload made by DJI, and it integrated a full-frame 45 megapixel CMOS sensor with 3 choices for the lens option. The first is 24 millimeters, and 35 millimeters, and 50 millimeters. And it is also equipped with 3-axis stabilized gimbal. And for how to use it, you can use it with Matrice 300 RTK platform, and with DJI Terra, you can real-time process it and do the post-processing. Zenmuse P1 is the first full-frame photogrammetry aerial payload made by DJI for 6 highlights listed in this page. The first is the accuracy. Without GCP requirements, it can achieve horizontal accuracy of 3 centimeters and vertical accuracy of 5 centimeters as well. And for the efficiency, it is also very high. Under one single flight, you can use it to cover 3 kilometers square area, and it is also with high resolution. The CMOS is 45 megapixels for frame CMOS sensor, and it is also equipped with 3-axis stabilized gimbal with smart oblique capture feature, which we will introduce it in detail
later. And for the shutter, it is a mechanical global shutter. The speed can be up to 1/2000 seconds. And it is also equipped with TimeSync 2.0 feature to achieve microsecond level system synchronization. For the first and second highlights, the condition is the same. The GSD is 3 centimeters with a front overlap ratio of 75% and side overlap ratio of 55%. For the design of Zenmuse P1, one highlight of it is the full frame image sensor. It is 45 megapixels for frame sensor, and the pixel size is 4.4 millimeters. And with no noise, high dynamic imaging, increasing daily operate time by 10%. And the time interval of it is 0.7 seconds, which is much less than 24 RDK or X7. And thanks because of the full frame CMOS sensor, we can achieve around more than 5 to 10 times efficiency compared with 24 RDK in both orthomosaic and oblique mapping missions. For TimeSync 2.0 feature, this feature improves the accuracy in two aspects. First, it can achieve microsecond level exposure, the middle exposure time period time capture. And the second part is that it can achieve millisecond level synchronization with camera, gimbal, flight controller, and RTK module. And then the system can do the corresponding real-time compensations. Like the first is the UV position and orbitation offset compensation, as the gimbal orbitation offset compensation, and then the camera position offset compensation. Besides, DJI P1 offers multiple choices for the primary lens. 24 millimeters and 35 millimeters and 50 millimeters. Normally, 35 millimeters is suitable for most mapping scenarios, but if you need to fly and operation altitudes to be higher, then you can choose 50 millimeters lens, and if your operation altitudes need to be lower, then you can choose 24-1. And besides, like we said, the mechanical global shutter can offer a better accuracy, as the TimeSync 2.0 can offer higher accuracy to synchronize to capture the microsecond level of the MEP and the microsecond level for the synchronization between different models. And here is an equation of the GSD under different lens options and a comparison with 24 RDK. One most important feature of Zenmuse P1 is the smart object capture feature. This feature enables Zenmuse P1 to achieve comparable efficiency compared to 5 object payloads. It actually works like this way. When P1 is perform a 5-directional object mission, it would swim 4 directions at minus 60 degrees and 1 direction at minus 90 degrees. So it can so the image capture efficiency is comparable to 5 object payloads. But when it flies at the edge area, like in this way, in this area, it would only capture the images inside the braking area. So it will take pictures, or it will swim in 4 directions. So compared to the 5 lens object payloads, the efficiency of the flight mission can be improved, and because there is less photos required to be captured when you are doing the post-processing work, the efficiency can be also increased by 20% to 50%. The second important feature is smart data management, which offers an intuitive, simple, and smart photogrammetry workflow. This feature actually makes 3 points. The first is an all-in-one storage for images, GIS data, and log files together. The second point is that the corresponding camera parameters will be drawn parameters, which also includes the RTK status, can be all automatically written into the image metadata. The third point is auto-generated server data folder can be patterned by mission name and time for easy use. So it means a lot for the user convenience and for the user values. The first is the easy of use. In this case, there will be no situation where the photo can't correspond to post data, which may potentially result unusable data set. The second is high organized. In this case, there's no need to verify and organize image post data, and there's no need to manually modify data sets, so it will be more convenient. The third point is highly integrated. In this case, information such as the camera position, orientation position, can all be saved in images captured, as the reconstruction experience with DJI Tabra can be simply import one folder, and then you can begin the process directly. And for the workflow of P1, first, the compatible UV platform is DJI Master 300 RTK, and the ground control app is DJI Pilot, and the data processing software could be DJI Tabra or other third-party data processing software. For the data capture, data capture progress, there is only 4 mission options available in DJI Pilot app, which is waypoints, photo mapping, uplink, and corridor. So there is some attention. Some of them are the difference between the Pilots and the GIS RTK app in Infinite RTK. The first is that the 5-way swing mode feature is available under photo mapping option, as the Pilots app does not have a separated terrain awareness mission option like GIS RTK app. So if you need to use to achieve the terrain awareness mission, you can directly import the DSM file under photo mapping option for terrain awareness needed. And compared to GIS RTK app, the Pilot app does not support mission options like the angled flight route, linear flight, adjustable height, as what we introduced in our last session about the newest firmware of NFO-RTK for 2.5, and also the 3D photogrammetry, double grid, and block segmentation as well. And for the data process, it is very simple actually, just like what we need to do for the NFO-RTK. Just import the data sets captured directly to DJI Tower to reconstruct the model, and then the data process workflow is just the same as the NFO-RTK. The multiple operation modes DJI Zenmuse P1 support includes 2D awesome mosaic, 3D uplink, and detailed reconstruction or real-time reconstruction. Here is a comparison with NFO-RTK and Zenmuse X7. For the weight, P1 is much higher than X7, and for the supported platforms, P1 only compatible with Matrix 300 RTK, while X7 is compatible with Matrix 200 Virtual Servos and Inspire 2. And for the supported lens options, P1 offers 3 choices: 24mm, 35mm for most suitable scenarios, and 50 meters, while X7 offers more. But In the four options offered by X7, only 24mm and 35mm is recommended for the usage of servering and mapping. And for 24RDK, it only provides a fixed focal length of 8.8mm. And for the CMOS, P1 is a full-frame CMOS with 45 megapixels, while X7 is S35 and P4R is 1-inch CMOS. And for the GSD equation, it is different. And here is for your reference. And for the pixels, yes, we just mentioned. And for the pixel size, it is also much larger than X7 and P4R. And the time interval is much shorter than X7 and P4R. So the efficiency of P1 is much larger than X7 solution and P4R solution actually. Here is an summary of the specifications. Most of them we already introduced in our previous page. And the weight is 787 grams. For one more thing need to notice is the IP rating. It is IP rating IP4X, so which means that it cannot be used in rainy weather. And actually, in rainy weather, serving missions cannot be executed. And another highlight is the effective pixels, pixel size, and the time interval, which is valuable to be promoted to our clients. So this is the detailed introduction to the basic parameters of Zenmuse P1 and the features of Zenmuse P1. So how about the applications and case studies? So we will go for the second part. For the suitable application scenario of P1, actually P1 is suitable for can be widely used in survey scenarios, including the topographic survey, the cadastral survey, AEC, natural resources survey, geological disaster survey, and emergency mapping survey. The first case I want to share is one case happened in Jianchuan Cave, which is located in Wuxia Canyon. Jianchuan Cave is located in the Wuxia section of the Three Gorges, which is well known in the world of the Yangtze River. And the river level at Jianchuan Cave has risen by more than 100 meters after the impoundment of the Three Gorges Reservoir area, and it fluctuates by 30 meters every year. So the oblique rock mass in the reservoir area has been deteriorating for a long time, so it is very dangerous. So in this case, the government of Jianchuan Cave is related to the safety of the Yangtze River channel. And before the usage of P1, the traditional challenges are a lot, mainly in three aspects. The first is the difficulty. Traditionally, geological survey will use SRT single rope lifting technology, requiring operators to climb to the corresponding area for on-site investigation, which is difficult and has a high risk factor, very dangerous for the operators. The second is the high resolution requirements. The observation accuracy of the dangerous rock mass cracked must reach the millimeter level, and the data must be collected very close to the wall. So it is almost impossible for the traditional surveying methods to do this work. And the third is the high precision, which means that in order to compare the cracks before and after, it is necessary to ensure the consistency of the two modeling results. In this case, P1 did offer a great result in this investigation work in four aspects. The first benefit is about the high resolution. Because of the 55 megapixels of the sensor, data with a resolution of up to 1.7 millimeters can be obtained at a distance of 20 meters from the rock, so the details of the crack can be seen clearly from the model, as the video shows here. The second benefit is on the high accuracy. P1 can synchronize with Metro 300 RTK microsecond clock to ensure the centimeter level accuracy of data collection because of the time sync 2.0 feature. And using P1 for data collection, the error of the results of the previous two modeling results in this case does not exceed 1 pixel. So it is very good on the accuracy. The second aspect is on efficiency. Because P1 has a full frame sensor, so one single photo can achieve large coverage. And because one single pixel size is 4.4 micrometers, so it can effectively extend the efficiency of a single day. And in this case, two flights totally complete the high quality 3D modeling work, data collection work in this case. And the fourth is about the three-axis gimbal system. It ensured the data, the modeling data collection in this case. And the second case is on the large area DOM in Shanxi province, China. The background is that in order to test the accuracy of Metro 300 RTK and P1 large area node GCP orthophotos, Shanxi Wendatong conduct a large-scale orthophoto project test in Datong City, Shanxi province. And in this case, the serial error is a typical plane error with a high difference of 130 meters. In this project, the flight height is 240 meters, GST is 3 centimeters, the front overlap ratio is 80%, and the side overlap ratio is 70%. The quantity of the image is around 6,000, and to achieve this data collection, the total flight times is 9 times in 1 day, and the data processing times is 9 hours, and the result is very, very good. Like the video shows in the right part of this page.
And then let's go for the introduction to Zenmuse L1, which is our LiDAR solution. And before the presentation, I'd like to also share our official video because I'd like to show our official introduction video of L1. And I hope you can collect some overview understanding of this product.
Imagine a new world, effortlessly digitized by an airborne LiDAR system. Today, meet the Zenmuse L1, a payload that combines the powers of both LiDAR and visible light. It enhances the 3D data capture capabilities of drones and enables you to recreate the world. The L1 integrates a LiveOx LiDAR module, a survey-grade camera, and a high-accuracy IMU on a 3-axis gimbal. It has a detection range of up to 450 meters, and the fusion of LiDAR and RGB data produces effective true color, high-density point clouds at the centimeter-accurate level. Infrastructure assets like bridges, power lines, and towers can be modeled precisely by the L1, so you can operate and maintain them safely and efficiently. In heavily foliaged areas, Its multi-return capability can penetrate vegetation canopies and capture point cloud data of ground features, as well as bare earth. Extract the vegetation point cloud to acquire information such as tree count, canopy width, and height. The remaining ground surface data can then be used to generate highly accurate digital elevation models for topographic maps. In areas with large changes in elevation, the Terrain Follow feature generates flight paths with variable heights to ensure the consistency of the point cloud data. Nighttime rescue missions in complex terrains have always been difficult. The L1 lets you view point cloud models in real time. Mark points, lines, and areas of interest on the live model to measure and annotate. You can verify fieldwork quality immediately and gain critical insight for on-site decision-making. The Zenmuse L1 forms an integrated solution with the Matrice 300 RTK and DJI Terra. This combo changes the game for the quick creation of true color point clouds and reality models. Upgrade your toolbox with the L1. Recreate your world in vivid 3D.
Okay, I'm not sure whether this video is played successfully, and but no worry, if we will share this video before your official roadshow, so no need to worry about this. And then let's continue for the introduction to the basic parameters and key features of Zenmuse L1. Okay, I hope this video can offer an overview understanding of this product. And as said, L1 is our first LiDAR solution. So we will go to introduce the detailed product parameters and features of it, and then go to introduce the applications and case studies. And for definition, DJI L1 is a highly integrated cost efficiency and easy to use enterprise LL LiDAR solution. And in this payload, we integrate a Livebox LiDAR sensor, a high precision IMU system,
1-inch CMOS visual camera, which equals to the payload of Phantom 4 RTK with mechanical shutter and 3-axis stabilized gimbal system. And you can also use it with Matrix 300 RTK and DJI Terra to use this to collect real-time and obtain real-time 3D point cloud for high accuracy and detailed reconstruction needs. So, and you can also use it for the vertical industries like energy, AC, forestry, and public safety as well. Regarding on the principle of the LiDAR system, I suppose it is easy to understand. First, we need to emit a pulsed IR light and then receive the reflect signal. So the phantom will travel, the distance of the travel of the phantom actually is doubled of the compared of the actual distance. So the measured distance equals to half of the phantom travel time plus the speed of light. Okay, so let's have an overview looking of this product. As we said, Zenmuse L1 is the first ever LiDAR payload made by DJI, and it is an all-in-one solution for surveying and mapping with high precision RMU. For the sensor integrated in this system, it includes one Livebox LiDAR sensor and one 1-inch CMOS sensor camera, which actually the parameters of it equals to the payload of Phantom 4 RTK. And it can also it also uses the mechanical shutter. And for the RMU system, actually it includes two models. One is the high precision RMU model. The other is the auxiliary vision sensor. It can achieve high accuracy. For vertical, it is up to 5 centimeters. For horizontal, it is up to 10 centimeters. And it can also achieve high efficiency. If you can actually, in one single flight, you can cover 2 kilometers square if the flight velocity is 10 meters per second and the flight height is 100 meters with a side overlap ratio of 20%. As the density point cloud can reach up to 250,000 effective points per second, as the multi returns, it supports 3 as the maximum, and the measurement range can be up to 450 meters, but it depends on the reflectivity of the objective. And for the IP rating, it is up to IP44, which enables to work in some horrible weathers. And for it also supports real-time point cloud review feature, enables to display and measure point cloud in real time with the Pilot app. And it also supports DJI Terra for post-processing. Further integrated live laser model. It is a frame lidar, which means that it can make sure all the points are valid. And for the measure range, if the reflectivity of the objective is only 10%, then we can reach 190 meters. And it supports three returns as maximum. And if we only take the first return, then it can achieve 240,000 effective points per second, and the FOV is 70 degree, and it supports 2 scan patterns. One is the non-repetitive pattern scan, like this video shows. In this mode, then in this pattern, then you can achieve a higher efficiency because it can run more faster. And the second pattern is the line scan pattern. It is a repetitive pattern. So if you are in this pattern, then the accuracy can be higher, but the efficiency compared to this pattern, it will be a little lower. And before using L1, please note one concept, which is the reflectivity. Because the reflectivity of the objective will have some influence on our result. For example, uh, if the reflectivity of the object is only 10%, then the maximum measuring distance is only 190 meters. But if the reflectivity is higher, then we can achieve a max measure distance as 450 meters, as we described before. And for reference, here is a forum to show the reflectivity of some surface type, like the desert. Then the reflectivity is around 24% to 28%, and if it is bare dirt, then the reflectivity is around 10% to 20%. If it is wet, then the reflectivity will be lower. If it is dry grass, then the reflectivity will be higher to from the 15% to 25%, etc. Three returns. Actually, it is highlights of LiDAR solution compared with the traditional aerial mapping and surveying payloads such as the Zenmuse P1, as we described before. With the multi-return, actually for L1 it supports 3 returns, and you can set the return number in a DJI Pad app. And for the benefits of multi-returns, first, traditional solution can only error solution can only measure the DSM, but with the multi-return of LiDAR solution, you can measure both DM and DSM. And you can use it to calculate the vegetation height, and it can also penetrate glass, so you can measure the object behind. For the camera module integrated in L1, we have 2 camera modules integrated in the system. The first is the 1-inch CMOS camera. It is with 20 megapixels 1-inch CMOS sensor, and it supports mechanical shutter, which means that actually the specification of it is the same with 24 RTK. It can provide real-time true color rendering data for LiDAR module, and this is one key point of it, differentiates it DJI L1 and other LiDAR sensors in the market. The other camera module is auxiliary vision sensor. It can assist in the IMU system. When the aircraft lost GNSS signal, the DJI L1 can continually use the auxiliary vision sensor to receive orientation data and maintain the system accuracy within a short period of time, which is 60 seconds. For the high accuracy IMU, actually, high accuracy IMU is the base for high accuracy LiDAR system, so it is a very, very important model. For DJI L1, it uses both the high accuracy IMU and its visual assistant camera, which we call it auxiliary vision sensor, to ensure the high accuracy IMU data output. Here is 2 forms to introduce the detailed accuracy of the system. For the first form, regarding on the IMU accuracy, I need to explain one thing in advance, which is the RTK and PPK mentioned in this form. The RTK result means you check the accuracy result on the Pad app when you are on site, and the PPK means that you check the result after the processing of DJI Terra. And the positioning accuracy in vertical direction, it is 5 cm and 5 cm for both RTK and PPK results. And for the horizontal accuracy, it can achieve 5 cm as the RTK result and 2 cm as the PPK result. And for the yaw MU accuracy in RTK result, it can achieve 0.18 degree, and in PPK result, it can achieve 0.08 degree. For the pitch and roll IMU accuracy, it can achieve 0.03 degree in RTK result and 0.025 degree in PPK result. And considering the entire system performance, if we fly at a recommended flight height, which is 50 to 100 meters, then the point cloud density of the target can reach 100 to 300 effective points per meter square, and the relative accuracy can reach 10 centimeters if the flight is 50 meters, and 5 centimeters in PPK result if the flight is 50 meters. And for the absolute accuracy, it is a little higher. In RTK results, then it can reach 15 centimeters if the flight is 50 meters, and in PPK result, it can be up to 10 centimeters if the flight height is 50 meters. And previously, we mentioned that Zenmuse L1 supports point cloud live view feature. And actually, this feature means that if you work on site, you can use the Pilot app to display point cloud in real time, and which enables you to gather first-handed information on field and provide data support for decision makers in a short time. And here are something to notice. The first one is that the model will be displayed in real time as L1 scans, and actually you can clear the display at any time if you want it. And you are able to switch the real-time point cloud viewer or between the visual camera viewer, and actually you can also set a split screen to display both. And for the color modes, we support three color modes. The first is reflectivity rate to show the color relevance to the reflectivity of the targets, or show the elevation, or uses in invisible mode. Visible means that it will display on the basis of the true color rendering. And in Pilot app, also you can use it to measure the position, distance, and aerial with the point cloud data. And also here also point of interest feature supported. You can add your point of interest on the model, and you can also drag or rotate or zoom the model with touch gestures. For the post-processing of the point cloud result, we can use DJI Tower to do it. And in future, DJI Tower version 2.4 will support Zenmuse L1 post-processing. And on how to use it, you can just select the LiDAR photo directory, and Tower would automatically identify point cloud data, photos, GNSS data, base station data, and IMU data. And then you can choose the color modes. And here are 4 choices. The first is visible and reflectivity rate, altitude, just like the choices on the Pilot app, as we explained before. And the fourth choice is the written numbers. For the output formats, we support PNTS, LAS, PLY, PCD, S3MB, and 3D mesh mode outputs as well, but it will be supported later. And for the measurement types, we support the point measurement, or the linear measurement, or the error measurement, or volumetric measurement. On the workflow of Zenmuse L1, you can use Matrix 300 RTK to carry it, and for the ground control app, DJI Pilot could help, and it is able to generate point count in real time. For the post-processing, we can use DJI Tower to do it. And for the data acquisition, you can plan the mission using DJI Pilot app with following mission options available: waypoints, photo mapping, and corridor. Two points to need to pay attention to. The first is that before the mission execution, you need to use Metric 300 RDK carry L1 to fly figure 8 for the celebration. And then you need to make sure to connect Metric 300 RDK to RDK network. Otherwise, DJI tablet will not process the data captured. And for the data process procedure, in DJI Tower, you need to set up an aerial photography task first, and then select the mapping scene as LiDAR post-processing and select the source folder containing LiDAR MU and inertial navigation data to start data processing. If the selected folder contains visible light photos, then the generated point cloud file is a visible light point cloud. Then regarding on the operation efficiency, here's some points to share. The first is on the recommended parameters. The flight height, we recommend you to set it as 100 meters. Then because of the FOV is around 70 degrees, so the extension range could be which is perpendicular to the heading direction, could be 140 meters. And the suggested side overlaps ratio should be 20%, and flight velocity could be 10 meters per second. And under these parameters, one single flight duration is around 30 minutes. For the process efficiency, if you need to check it on site, then the point cloud will be the result will be showed in seconds. And if you need to check the post-process model, then the efficiency is less than 30 minutes per craft. For the result, one single flight will cover around 2 square kilometers, and the point cloud density under these recommended parameters could be 214 points per square meters. To summarize the specification of Zenmuse L1, first on the weight of it, it is 900 grams. For the IP rating, it is IP44. For the measurement range, if the reflectivity is only 10%, then it can be up to 190 meters. And if the reflectivity is enough, then it can be up to 450 meters. On the typical operating altitude, it could be from 50 meters to 150 meters. And if the soaring accuracy on a height of 100 meters, it could reach 3 centimeters. For the point rate, if you set on the DJI Pad app to receive the first return only or receive the strongest return only, then the point rate could be 250,000 points per second. If we choose to receive the dual return or even the 3 returns as the maximum, then the point rate could be 480,000 effective points per second. They are the same. For the scanning patterns, we have two choices. The first is the non-repetitive pattern scan, and the line scan. The FOV in these two patterns are different. For the horizontal FOV of non-repetitive pattern scan, it is around 70.4 degree and 77.2 degree in vertical. And for the line scan, the FOV in horizontal are the same, but the vertical is only 4.5 degree. For returns, we can receive 3 returns as the maximum. For the IMU update frequency, it is 200 Hz. And for the IMU yaw accuracy, it is 0.08 degrees in PPK result. And for the pitch and roll accuracy, it is 0.025 degrees in PPK result. For the visual sensor effective pixels, it is 20 megapixels, just the same as the 24 RDK. Here is a simple comparison among three solutions. The first is the Matrix 300 RTK and the DJI L1 or Zenmuse L1. And the second is the Matrix 300 RTK and Zenmuse P1. And the third is Fanful RTK. For the pros of the first solution, Matrix 300 RTK and Zenmuse L1, the first point is it is highly adaptable. If we operate with LiDAR system, we do not rely on the environmental lighting condition or target texture because it is an active detection method. And it can collect elevation data in dense vegetation field, which means it is able to extract both DM and DSM. And we can use it for high density modeling on detailed subjects. For structures need detailed and accurate modeling, such as the power lines and bridges. And it is also highly efficient. Under one single flight, we can use it to cover 2 square miles. For the cons of this LiDAR solution, the first is that it is not suitable for 2D reconstruction use because it is mainly designed for 3D reconstruction. And if we use it, we will rely on initial pose state because the initial pose state will have very essential influence on the final accuracy of the result. Then considering the Matrix 300 RTK and Zenmuse P1, first, with this solution, we can use it for multiple operation modes, such as the 2D awesome mosaic, 3D oblique, and corridor mapping. The second is that it is highly efficient. With under one single flight, we can use it to cover 1 square miles of 2D awesome mosaic, and it is also highly accurate. If without GCP conditions, we can achieve 1 to 500 serving level accuracy data. And the resolution is also high because it is equipped with 55 megapixels for frame CMOS sensor. For the cons of it, first, it is unable to conduct DM reconstruction compared with L1 solution. And the reconstruction efficiency compared with L1, it is a little lower. And it is also unable to operate at night time and unable to reconstruct the area with no visual texture because it is a kind of passive detection method compared with the LiDAR system. For the solution of Fanful RTK, the most important benefits of it, the pros of it, is that it is with low entry barrier. It is cost efficient because it is cheaper. And it also supports multiple operation modes because the JS RTK app are even more powerful than Pilot app. It integrates multiple intuitive mission planning modes for different applications. It can generate waypoints and a flight route automatically with few parameters determined. So it is also easy to use. And it is also a highly integrated AIU form factor, and it is also portable to be carried compared with the previous two solutions. For the cons of it, first, the operating efficiency is comparably lower compared with P1 or L1, and because P1 can the efficiency of it can be comparable with the 5-learn solution, and the resolution is a little lower because it is only 20 megapixels because it is an old design actually. And it is not suitable for large area operations because the limitation of the duration. And the fourth point is that it is unable to operate at night time, unable to reconstruct the area without visual texture. Here is some FAQs for your reference. So let's go through the first question. What is the recommended parameters for operating DJI L1? As we said previously, as we said several times. So first we can select the mapping or corridor mission model to plan the mission, and the relative altitude could be 50 meters, velocity could be 5 meters per second, and the side to overlap region ratio could be 50% and enable celebrated flight. The second question, why we need to fly figure 8? It is very important for celebrating the RMU and improve the system accuracy. So please do not forget it if you need to execute one mission. The third is that what is the FOV on the DJI L1 LiDAR sensor? Because we have two patterns. On the non-repetitive pattern scan pattern, the FOV in horizontal direction is 70.4 degrees, and in vertical direction it is 77.2 degrees. If we use it with the line scan pattern, then the FOV in horizontal pattern is the same with the non-repetitive pattern scan pattern, which is 74 degree and in horizontal direction, and with the 4.5 degree in vertical direction. The fourth question, what is the difference between repetitive scanning pattern and a non-repetitive scanning pattern? The non-repetitive scanning pattern differs significantly from the repetitive linear scanning offered by traditional LiDAR sensors. The average scan inside the FOV of a horizontal sensor grew the longer the integration time, increasing the likelihood of objects and other details within the FOV being detected. To make it simple, it is that if we use the repetitive scanning pattern, then the accuracy could be higher, but the efficiency could be lower. If we use the non-repetitive scanning pattern, then the efficiency could be higher, while the accuracy will be lower comparably. The fifth question, what is the visible assistant camera built into the DJI L1 is for? It means that when the aircraft lost GNSS signal, and then the visual assistant camera can receive the orientation data and maintain the accuracy within a short period of times in 1 minute, actually. And the sixth question, when using DJI L1 with the Matrix 300K, is PBK supported? Yes. The mission folder generated would include point cloud data, photos, and GNSS observation data, and exposure log for PBK process. Okay, I suppose by now we already know the basic parameters of Zenmuse L1 and the basic features of it. So in the second part, we will share some of our thoughts on the applications and case studies of this product. Because this is our first LiDAR system, our LiDAR solution for our aerial surveying and mapping scenarios. So some sharing on the customer base. First, about the target customer base. Actually, L1 it is designed for customers seeking for high accuracy aerial surveying solutions, especially in energy and AC fields for desired detailed reconstruction or inspection use. And considering the expand customer base, we can promote this for data sensitive users, like the users in forestry management, public safety works, or even emergency responders. And for the scenarios, it can be mainly promoted in four scenarios: the topography survey, the infrastructure reconstruction, the forestry, and the emergency mapping survey. First, we'd like to share a case for the topographic survey. The background of this case is that in Qingyuan, one city of China, we use Matrix 300K to carry L1 and turn on the dual alcohol mode and perform the which means dual returns, and perform the topographic map extraction test in a forest nearby the Qingmen. And the survey area richly includes vegetation, roads, power lines, houses, ponds, and other things. The workflow of this case is actually simple. We use DJI to process raw data and output the last file, and then we use third-party software to do the feature extraction, vegetation analysis. So while in this case, we finally get the tree classification, like this image shows, and we also collect the DM and the contour lines. It is very good result. And the second case we'd like to share is a detailed bridge inspection case. The background of this case, actually, it is about a bridge between two cities. It is the Shanghai Sutong Yangtze River Bridge, which is a bridge connecting Suzhou and Nantong, two cities. It is a road and a river bridge with a total length of 11 kilometers, of which the main bridge is about 6 kilometers, and the shooting mainly focused on the 6 kilometers main bridge. The workflow of this case is also simple. We use the corridor mission planning to scan the bridge in different heights at a velocity of 5 meters per second to capture all the data and then import all the raw data to DJI Tower for post-processing. And the result is also very good. And the third case is about the power line grid. The background of this case is that it is a power line grid point cloud data. They were collected in Hunan province, which is used for tree barrier analysis, and the total length is about 800 meters. In this case, we also used the corridor flight mission planning, and the data collection was completed in only 2 routes and 5 minutes. And we used DJI Tower for data processing and completed the high precision last point clouds output in 3 minutes. If we compare this usage with 54RTK, to obtain the same point cloud accuracy, a ball-shaped route is required, and the 800-meter line needs at least 30 minutes to collect, and we need to collect about 400 photos, and the reconstruction takes about 20 meters. And we also used the solution in oil and gas industry with Rosneft and Argeo. In this case, we use it to cover 8.5 hectare area around the river crossed by Rosneft pipeline. And in this area, there are freestanding trees, buildings, roads, meadows, a river, and oil infrastructure constructions. The initial processing produced a georeferenced point cloud modeling containing 18 million points, and the final model had an average density of more than 1,000 points per meter square. It is very good. And we also used this product to support our clients in Indonesia. We use it to support Pertamina geothermal energy in West Java, Indonesia, and we use this for elevation modeling. We use it for vegetation mapping and right-of-way analysis, and we use it as build LiDAR scanning and 3D modeling for maintenance management and EPC. And we also used it for infrastructure management to support hosting engineering. And our partner said that in hosting engineers work on road grading and widening, they found an area LiDAR solution like the Metro 300K and Zenmuse L1 to be extremely valuable, as it is capable of mapping vertical slopes, generates data live in the field with field reports to minimize rework, and has specialized optimizations made for corridor mapping, which help keep crews off the roads to ensure safety. and the highly integrated payload sensor can be a game changer for many business. So here is some introduction on the DJI, both our new payloads, both Zenmuse P1 and Zenmuse L1. So if you have any questions, please raise them in the question box, and we are glad to offer answers one by one in turn.
Hello guys. Thank you for listening to this webinar, and this is Sima, and I will support with Rainer and together to answer the questions that you guys may all have. Let's before I jump in, just want to double check. Can you guys hear me okay? Okay, cool. All right, so let's go to beginning and answer the questions that you guys may have from very beginning. All right, so let's see the questions that I have. What are the requirements? Hold on one second. What are the requirements for the DSM for terrain follows? I think it depends, right? Because the DSM for terrain follow, I think you're referring to the P1, right? So if that's the P1, so there are two ways that we can do the perform terrain follows. The first option, just like the P4RT case, that you actually need to have like geographical coordinate systems. That means it's non-projected, like DSM data, and has the TFW file associated with it, import it. And second option is that we also gonna have, we're also gonna have the default like SRTM database, which built into the software, and then when you use that, it can perform the terrain follow based on that. But please be aware that for now, terrain follow functions is not yet ready for the P1. So when you guys order it and receive the units, and that function may have a little bit of delay. But what I can tell you is that it will definitely be there. It's just sooner or later, it's all about timing. So is there a PPK workflow for P1? So yes, we do have just like the P4RTK that we will generate the PPK related data, for example, like timestamp files and satellite observation files. So you can use that data to process it in any third-party PPK software. It's just for now, DJI doesn't support the cloud PPK solution for P1 yet, but it may in the future. What is the expected lifespan for mechanical shutter for the P1 and can just shutter mechanism and be replaced? Again, one more thing is that I think, as Rainer already mentioned, that so the timing is we are estimating have like 100,000 times. It's not the end of life. It just normally after 100,000 times, when you guys aware, for example, like when you take images or do some missions, and after 100,000 times, and you see that images are getting a little bit blurred and not very accurate, and you send back to the after sales teams, so they're gonna do evaluations if it's because of the shutters, and they may they will just replace a new one for you, and or do some necessary maintenance for that. Is the P1 weather protected? No, it's because that's really dedicated design for surveying and mappings that we believe that not many people will do a surveying and mapping job at very nasty day, so it's not protected. Also, distortion profile data of the lens enable like the P4RTK. Yes. Will the flight speed be automatically reduced when performing the swing capture mode? No, it won't, because that when you do the DJI pilots to plan the missions, it will automatically set up the maximum speed based on the missions that you have. So you don't really have to worry that part. Are the X7 lenses compatible with the P1? No, never do that. X7 lenses are not compatible with P1. Which mapping mode did you use to capture data in the canyon? So basically that one is for now is we actually fly it like manually, use DJI pilots and to capture the data. Um, what is accuracy when flying at 10 meters per second at 100 meters height with the L1? So roughly, we're estimating, for example, like the reference that the accuracy is that when we fly like 50 meters, so the relative height is around like 5 centimeters and absolute are 10 centimeters. So if you're flying around like 100 meters, so I would say the absolute accuracy are definitely within 15 centimeters for sure. Please explain more specifically to apply RGB values on point cloud, like which program need to process messages, use post-processing program or third party. Sure. So the thing is that DJI Terra will process and generates the true color point cloud data at LAS formats. Then you can use software, for example, like Terra Solid and Cyclone and TBC and those type of software and LP360s to analysis the point cloud to create, for example, like contour lines or to do the classifications. And true color always give people, because we see the world in the true color ways. So that will give customers and the people a more realistic, display on the point cloud data. So L1 provides that. So for now, if you want to generate the last file, so you have to use DJI Terra to import all the raw data from lidars, IMUs, and RTKs, and that's pretty much like very simple. You can simply import entire folders that contain all the data into DJI Terra, and it'll process for you. Are very easy to use. You don't have to understand. You don't need to really just kind of like drag different separate files to different locations. So a one file contain everything for emissions and processed it in DJI Terra. That's it, and it will give you a standardized last file. Can you perform PPK processing using DJI Terra? So actually, if you're talking about P1, no. Well, basically, it's that you need to create a standardized, or generate. If we're talking about P1, because we don't do the cloud PPK solutions by our side, but if you use third-party PPK software, make sure that it can output, the Excel formats, the post data that is exactly match the post files that are being generated by the cloud PPK solutions, and import that file into with the images, and then import to DJI Terra to process it. That's option one. And if we're talking about L1s, actually, when you process the data of the L1, so it actually uses the PPK ways to process it, because you need to have like RTK, the base station data, and also you need to have, for example, like all the RTK and base station files, and that is actually designed, for PPK processing in DJI Terra. If so, what formats of Rhinex data will it accept? It's just like the P4 RTK. It's the same. But like I said, for P1, there is no PPK solutions for DJI Terra. You need to use third-party software to process it for PPK. Does Point Cloud Live View has RGB values? Yes, it also has the RGB views as well. Will Terra be able to generate a DEM, or will it separate tool to be needed? No, Terra will not generate a DEM. Will there be a reference charters for flight speed versus height and on point cloud densities? That's a good suggestion. I will definitely consider that and make a table for you guys as a reference. What is the minimum sensing distance? So it depends, right? So if you're talking about LiDAR, like really there's not much like minimum sensing distance. But if you're talking about like a P1, it depends on, the GSD that you're looking at. But normally, I think our system will set up the flight altitude above like 30 meters, I think. What is the maximum movement speed the auxiliary camera can support for SLAM? So like I said, it's not when you do the mission planning, it's not like you control the speed. It's actually that when you set up the missions, the maximum speed is already being intelligently calculated. So that speed is okay for auxiliary camera to support a SLAM. So you don't have to worry that. But if you're doing the manual flights, I would imagine that it's not accurate measurements. So you know, if the data is already not accurate enough, so there is no point that we need to consider the SLAM or the auxiliary camera. Can the data be RTK processed in PPK? I mean, we take the data from the L1 and DRTK2 and then process the post-processing the event. We have area where there is a lost location connection for remote. Yes, yes. You basically import, like I said, just contain. When you use L1 to fly, actually they will create a big folder. So you actually just drag that folder into DJI Terra and it will process it in the PPK way. Why do the accuracy figures keep changing from slide by slide? What is the actual accuracy for the systems? So the accuracy, it depends on the height you fly, right? So the accuracy that we can tell is that one, the relative accuracy when we fly 50 meters, it's 5 centimeters relevant accuracy and 10 centimeters absolute accuracy. So that's the key figures that you need to remember. Please kindly specify how to perform PPK with this data, and I already mentioned that. Can we use third-party APPs to fly the? For now, you cannot use third-party APPs to fly M300 plus L1. The 16mm lenses are not able to use with P1. The estimated time that you can have the products are roughly, assuming that the sales rep already communicated with you guys, but you can expect that in the early next year. Yes, you can use CourseNet for sure. Because that the X7 lens is not designed for surveying and mapping at the very beginning. So the lens that we offer this time with the P1 is actually individually calibrated, and also we will track the records and the usage as well. So if you use the lenses from X7, one is it will not support mission planning. Two is that if that lens caused your system damage, and we may not guarantee the requirement, the repair or replacements. How to perform PPK with L1? You simply use the L1 to do the mission planning, and it will create a folder containing all the data. Then you import all the data as a folder to DJI Terra, and it will process it for you. So from functionality perspective, if you use the lenses from X7, you can do the manual, you can capture the images like manually, and that's okay. But it doesn't support all the functions. It doesn't support mission planning, And like I said, if you use that lens with the P1, you will. I mean, if that because of that it causes any damages of the lenses and other problems, and it may cause after sales issues. And that's why we said do not use lenses from X7. We never, how can you achieve 3 centimeter surveying accuracy? I think 3 centimeter surveying accuracy are referring to P1, not L1. 3 centimeter accuracy for P1 is the horizontal accuracy that we can achieve 3 centimeter accuracy. Um, can you use third-party base station with P1 and L1? Theoretically, yes, just like the P4RT case, and you need to set up your third-party base station as a server and log into Ntrip account. Actually, like if you guys search on the Googles and YouTubes, like like several months ago, that we together with Trimple and we jointly develop documents that how basically Trimple we actually support like Trimple R12 base stations. And on that document, it basically tells you guys how to set up the Trimple R12 to work with the DJI drones. And basically, you simply need to set up the base as the server, and log into the P4RTK, so that will support as well. But we don't do any direct support, but it will work on that way. Just search it on the internet, you will find documents. Can you use NetRTK on M300 via 4G? No, it doesn't support for 4G. And yes, the Ntrip will support for both L1 and P1. It's not a problem. Any other questions that you guys have? All right, so we're gonna wait for okay. Can I apply third-party Runx for PPK on Terra? Well, so I would say it's not 100% no, but you need to make sure. So once you have you get a chance to process it, it fly the L1s and go to the folders, and it will generate all the PPK related data formats. Make sure that the format is matching exactly the formats that the L1 already produced. But for me, I don't think there is any need. You need to use third-party Runx PPK to process Terra because for L1, because the M300 RTKs, when you connect with the base stations, when logging to the core stations, the system will already record all the needed data for you to process. So there is no need for other PPK data collections. What mapping mode did you use to collect data in Canning? Like I said, that one is we do the manual flights. We manually fly it, use DJI pilots. There is no mission planning. The sample data sets that, yes, we will send you guys the sample data sets, but for now, it just, we're still preparing some data sets because that's actually a universal command. Like people ask that from anywhere around the earth. So we need to make sure that this time we have official channels that we can have those data, and you guys can download it and use it and test it. Okay, we will check on that for sure. I have no time for that, but we will try our best. Okay, 2 more minutes.你这个拍一下，拍一下发给那个。这个不是漏的，这个他那个倒无所谓的，跟他说一下。
CRK 对，今年已经被投诉了3.1万澳币和19500澳币。那个截个图发给 Chris 了。谁说的？啊，我知道了。那个 Holly 下面的二代，另一家的代理下面的二代，他就10天干了一个。
我是回答过的，
我知道。
他可能没听见吧。Okay, thank you guys. Thank you for today's webinar, and please let us know if you guys have more questions, and feel free to email us. We're more than happy to support. Thank you.